Welcome. In today's presentation, I will be discussing triphasic training, a strength and conditioning system developed by Carl Dietz, and critically analyzing its application in football, particularly in the preseason versus in-season periods. I'll guide you through the principles behind the training system, the evidence supporting each phase, and then we'll dive deeper into how this system can or cannot be adapted to meet the demands of high-performance athletes during the competitive season. Triphasic training is built around three core phases of muscle action. The eccentric phase focuses on controlled muscle lengthening to improve force absorption. The isometric phase, which focuses on holding the muscle in key position and targets joint stability and strength. And finally, the concentric phase, which develops explosive power through forceful muscle shortening. The system is designed to improve strength and power through structured block periodization. Each block lasts 2 to 3 weeks, designed to optimize progressive overload and develop specific neuromuscular adaptations. In theory, this approach should maximize athletic performance, particularly in sports like football that require rapid change of direction, deceleration, and acceleration. The aim of this presentation is to critically evaluate the effectiveness of the system supported by scientific evidence and to explore how it can be integrated into football teams' training schedule, both pre-season and in-season. So, eccentric training targets the lengthening phase of muscle action, producing high force while absorbing mechanical energy. This phase is especially important for athletes who need to decelerate quickly after a sprint or when changing direction during matches. On the left side, we see the force velocity curve for different muscle action. Eccentric contraction produces the highest forces at lower velocities. This is crucial during movements such as deceleration, where the ability to generate high force while controlling muscle lengthening is key. The curve shows the maximal eccentric strength is much higher than both maximal isometric and maximal concentric strength, making it ideal phase for force absorption. On the right, we see the traditional method refers to typical resistance training where the loads are balanced in both concentric and eccentric phases of an exercise. In contrast, augmented eccentric loading, IEL, increase the load specifically during the eccentric phase. This difference is important because, as seen in the graph, the EAL method leads to greater improvements in eccentric strength, which is particularly beneficial for athletes who need to control high forces during deceleration and change of direction. However, the eccentric training improves important physiological aspects. This type of training leads to significant muscle damage, decreased force production, and increased muscle fatigue, which takes several days to recover from. This graph highlights the need for extended recovery periods following eccentric training, particularly in sport where frequent performance is required. The isometric phase is crucial for improving joint-specific strength and rate of force development, particularly in angles of high mechanical disadvantage. Isometric training can be particularly beneficial during movements such as sprinting, acceleration, and cutting, where athletes must stabilize their body briefly before an explosive movement. The static force production is key to success in those movements. One of the main advantages of isometric training is low energy demand, making it perfect for in-season training when athletes need to maintain strength without accumulating too much fatigue. However, while isometric training improves static strength, its transfers to dynamic activities such as sprinting or jumping may be limited unless it's combined with dynamic training. Looking at the graph, we see a comparison between concentric training, sustained isometric strength training, and rapid isometric strength training. The sustained isometric strength training group showed the greatest gains in CMJ height and isometric squat force, indicating its superiority for improving both static strength and explosive power. In contrast, the concentric training group had lower improvements in isometric force, but likely performed better in dynamic movements such as sprinting due to the nature of concentric contractions. The concentric phase is the muscle shortening action that occurs when force is produced to lift a load. It's critical for sports that require explosive actions such as sprinting and jumping. Concentric training improves force output, particularly in strength-focused exercises. This can enhance performance in power-dominant sports, contributing for increased sprint speed and jump height. However, while concentric training improves force production, it doesn't offer the same benefits in terms of tendon stiffness and force absorption, which are crucial for activities such as rapid deceleration and change of direction. On the left side, figure A shows an increase in force at peak power over time, indicating improved strength with training. Figure B demonstrates that explosive power increases as training progresses, highlighting the benefits of strength training for power development. On the right side, the graph compares the effects of concentric strength and power training on leg muscle mass. Concentric strength training led to a steady increase in muscle mass with a 5% increase by the end of the study. In contrast, power training showed no significant change, suggesting it's less effective for muscle hypertrophy compared to strength training. This example shows how triphasing applies in different loading parameters across Monday and Friday, targeting specific strength qualities through eccentric, isometrics, and concentric phases. On Monday, we start with medium intensity using loads of 82 to 87% of 1RM. The focus is on slow eccentric movements with 6:00 tempo followed by isometric hold at 0:30 and finishing with fast concentric movements at 0 tempo. These sets found the foundation for strength development. For the eccentric phase, we do 1 to 3 reps with 2 to 4 sets. And for the isometric, it will be 1 to 3 reps, but with 3 to 5 sets. On Friday, emphasizes the higher volume, but at lower intensities, around 75 to 80% of 1RM. Eccentric work is done at 5:00 tempo, followed by isometrics hold with a 3:10, and finally concentric power at 0 tempo. The adaptation goes by cycling through these phases and varying intensity. Athletes can progressively develop the force absorption during the eccentric phase, joint stability in isometric phase, and explosive power in the concentric phase. This ensures comprehensive strength development across the entire block. With football's year-round competition, managing volume and intensity effectively is essential, especially during the preseason and in-season phases. In the preseason, block periodization is ideal for using triphasing training. There is no more time for recovery and progressive overload. Athletes can be dedicated to specific blocks to high volume in eccentric and isometric work, building strength through focus phases without the need for immediate performance in matches. During this time, athletes can develop strength, improve force absorption, i.e. eccentric phase, in joint stability, isometric phase that supports better concentric power later in the season. One of the main challenges of applying triphasing training, particularly in season, is the management of volume and intensity. During the in-season, athletes have limited recovery time between matches. As Kramer at Ratmas cautioned, too much high-intensity eccentric or isometric work during this time could lead to overreaching if not monitoring carefully. Instead, shorter modified version of triphasic training could be used. Managing this carefully is crucial for maintaining performance while avoiding excessive fatigue. Prioritize concentric and explosive work to maintain power output and speed without compromising recovery during in-season period. In addition, Rea et al. Found that undulating periodization, where intensity varied more frequently, could provide better adaptations for athletes, especially when managing fatigue across the long season. When looking for an alternative to triphasic training, contrast training can be a very good option. So in general, contrast training involves pairing heavy resistance exercise with explosive power movement to improve both strength and power in the same session. The key mechanism here is the post-activation potentiation, PAP, which primes the nervous system for greater power output. For football players, contrast training provides an effective way to train multiple fitness qualities in the same session, such as strength and explosive power. During the in-season period, this method helped to maintain neuromuscular coordination and power output without overloading any single area. While three-phasing training focuses on distinct phases of muscle contraction, contrast training is more suitable for in-season when time is limited. It allows for simultaneous strength and power development. However, it lacks the phase-specific development and better suited for short-term performance improvement rather than long-term strength development. If we look at this contrast training program example, this program combines heavy resistance exercises in 70 to 85% of 1RM with explosive plyometrics movements. Each week focus on a mix of strength exercise, i.e. squat, lunges, paired with jumps such as step jumps, box jumps, maximizing the PAP for enhanced power output. So to conclude, three-phasic training is more effective during the preseason period. It provides a structured approach by focusing on distinct phases, such as the eccentric, isometric, and concentric, allowing athletes to build strength and power systematically over time. In contrast, the contrast training is more suitable for the in-season when time is limited. It allows athletes to train both strength and power in the same session, maximizing efficiency. The use of PAP enhances their ability to maintain performance level during the demanding season. Both methods can be useful depending on the specific need of the season and players' performance goals. Thank you.